Well, thank you, everybody. My name is Peter Benisti. I'm VP of Business Development for a company called Positron. So Positron is headquartered in Montreal, about an hour and 45 minutes from here. And we've been around for about 55 years. We make telecom gear. Our customers are ISPs. We have about 250 ISP customers across the US and Canada. 90% of our business is in the US. We have a lot of tier threes, tier fours, a couple of tier ones, and many tier twos using our product. We also started doing work with some cable operators. We've been involved in many digital equity projects. Obviously, we are very interested in having the ability to provide our equipment for ISPs and cable operators that are participating in the BEAD program. One point I'd like to make about what we do is that we are 100% focused on the MDU. So the single family unit is not in play for us. And the reason being is we've developed a technology using gigabit home networking, G.hn, to allow you to leverage the in-building wiring, which up until a few years ago, the most you can get was your VDSL2, which should give you like maybe 50, 100 meg. Today, we can push 100, or I should say a gig symmetrical in every direction, in upstream and downstream, over telephone wire, the old Cat3 telephone wire, or even RG59 coax. So it makes it really exciting for projects where you can get fiber to the MDU, or you can get millimeter wave to the MDU, or like I was asking the folks at Starlink, if you can get backhaul to areas where you have line of sight problems for millimeter wave, anything that you can get backhaul broadband to, but becomes a challenge to run fiber or install new wiring like Cat6, this is where we fit. Okay. So a little bit about that focus on that, last mile, as you mentioned, Christine. It's a little less than the last mile. It's sometimes just a few hundred feet. And the problem is broadband service providers, typically have fiber going to the curb almost everywhere in the United States and Canada. That's not the problem. Many times the problem is I'll go out on the job site and they'll say, you see that pole over there? That's got fiber, but I can't get it over here, right? And that becomes the problem. So in the case of buildings, in the case of single family units, many times it becomes quite easy to get the fiber to the house because it's either a pole and they run it sometimes not even underground, they run it overground, but they get the fiber to the single family unit and you're dealing with a single owner and it becomes relatively easy to get the fiber to the house. Not always, but if you look at what most of our customers have been saying, the single family units was the easy stuff. The hard stuff becomes the multi-dwelling units. And that's the problem because you get the fiber to the building, but then you're in the building and you start to see, oh, wait a minute, this is going to be really difficult, right? One, you've got to get the consent of the property owner. Two, if you're trying to run your wire. Two, you have to make sure that the property is not too old. Sometimes if it's old, especially in the Northeast here, we see that a lot of these buildings have asbestos in them and you cannot, there's some federal laws, you're not allowed to cut a square bigger than 4 inches, some places 2 inches. So that becomes a problem. And then of course it's the cost. The cost is the biggest factor because many times you have concrete, you have very old structures that make it very difficult to run new fiber. And that becomes a problem. And this is really what we're solving. We're allowing you to light up that fiber by leveraging what's already in the building. We're not looking at running any wiring in the building. We're looking at basically reusing that, Cat3 telephone wire or the coax that's already there. So a couple of things happened in the last years. Back in February 2022, you're probably familiar that the FCC changed the regulatory framework that said you're not allowed to have these exclusive lease and buyback agreements, which meant that you were basically, having an exclusive relationship. They're trying to change this whole kind of idea of a bulk deal as well. And it's all about increasing competition, making it more affordable and making it more of a choice for the subscribers. Now, what that means essentially is that if you are running new Cat5 wiring typically that means that you, as a service provider, are going to have to share that infrastructure if somebody else wants to offer services in that building. Fiber is a little more contentious, but it's really opened the door mostly for the coax that's in the building. So the cable operators that have said, over the past years, that coax belongs to us, that FCC ruling kind of stopped that. Fiber is an exception. We know that fiber becomes very contentious. You will definitely have a fight with the incumbent operator if you're trying to use their fiber. But the telephone wire is never an issue. The coax is never an issue, and that means that it's that new FCC ruling just made it easier for you to use that wiring. One of the biggest problems, as I mentioned, is the heavy construction, the expensive upgrades in the brownfields. And if you look at the market, it's roughly that 80-20 rule. About 80% of the properties that are out there are more than 30 years old, and they are the target market for this type of technology. So I'm not sure how many of you have heard of G.hn. It's about 10 years old. Technology has been around. The initial wave of G.hn, which stands for Gigabit Home Networking, was to develop a broadband network over the power cables, 110 voltage wiring. This is something that never really took off, but it had some interesting characteristics that it kind of carried itself over to the spec in 2016, where they extended it to provide up to 1.7 gig of dynamic bandwidth allocation for telephone wire and coax. And that is that it is very resilient to noise. So you're probably familiar with G.fast, which is the extension of DSL technologies, ADSL, VDSL, then G.fast. G.fast never really took off because of its very high sensitivity to noise. It's a very susceptible signal. And pretty much every large operator that was planning to deploy G.fast stopped dry without deploying it. It was supposed to be the answer to what we're doing here, which is that if you can't run fiber, use the telephone wire. But it became very sensitive to noise. And I heard a presentation about 7 years ago where Verizon said, MDUs are like snowflakes, no two are alike, and G.fast, cannot adapt. I mean, sometimes you're trying to offer a gig and you're getting 200 meg, sometimes you're getting 500 meg, sometimes you're getting 150 meg, and that was a big problem. So what G.hn did is, with that resiliency to noise that was developed for the network over power cables, it kind of took that with it. It becomes a really resilient service over telephone wire and coax, and we'll see what kind of speeds we can deliver. Essentially, we have two different products, one for the Cat3 telephone wiring. So this is your twisted pair version. And then there's one for coax. So on twisted pair, we can do MIMO or SISO, single input, single output, which means one pair. So even if you have just one pair in the apartment, you can get a gig symmetrical to roughly, you can't see the chart too much, but where the star is, that's 500 feet, 150 meters, okay? So it's better than gigabit Ethernet. Gigabit Ethernet is 100 meters, which is 330 feet, which is usually okay for most locations. The problem is, if you don't have the Cat5, Cat5e, or Cat6, you're not able to get that gig symmetrical. So this is, and quite frankly, our product is essentially a gigabit Ethernet switch. It's just that there is that G.hn technology at every port to convert gig Ethernet to G.hn, and we're going to see that on the endpoint, it converts back to the gig Ethernet for the residential gateway. But essentially, with two pairs over telephone wire, I can go out all the way to 820 feet. So if I had a large, campus environment like this, or maybe a manufacturing plant, and I need more than 500 feet, and I've got two pairs of copper, I can get that gig symmetrical to 820 feet. Coax is a lot more performant.
Question in the chat. Is it okay to interrupt?
Oh, yeah, absolutely.
Okay. The question is, can you run both internet and phone on the same wire?
Internet, and yes, you can. Yeah, and that's because, and I can get into that, but there's probably 4 different ways you can have both of this over your telephone, and that would be either, the most common would be VoIP, of course, and people that have, I have customers in New York and in the Bronx and Brooklyn, where the residents are using the older telephones, right? The POTS telephones. So then they put an ATA next to the phone, or they get a Wi-Fi router that has a built-in ATA. And that allows you to use that POTS telephone, even though it's on a VoIP service. Or you can get a VoIP telephone and then you're on a VoIP service. Or you can get a POTS telephone over the twisted pair and use a POTS splitter, just like you had for VDSL or ADSL. And that runs the same way over the same pair of telephone. So the really neat thing about the coax version is the distance that you'll get. With RG59, which is the lower quality coax, you can get a gig symmetrical to 1,000 feet. What you typically find in MDUs is RG6, and we can do a gig symmetrical to 2,600 feet, which is amazing. And the hardwire between MDUs is often RG11, and that'll give you a gig symmetrical to 3,600 feet. Okay, so the distance is really not an issue with the coax. And another advantage of the coax, which is why it is by far the #1 product that our ISPs will look to use, is the fact that you can do point to multi-point. Okay, and that means that I could use a single port and I can split that port 16 ways. Okay, so if I have a gig symmetrical on a port, I can easily offer a 100 meg symmetrical service to 16 subscribers. So you could see how cost effective that could be, right? I could use a 4-port, split it 64 ways and offer 100 meg symmetrical. I'm definitely within the B spec. If I split the port, which is more common with our customers, 4 ways, 6 ways, or 8 ways, I can easily offer a gig symmetrical because of the under subscription.
And a quick question, this is untapped or tapped, or the total distance, tapped or untapped?
Tapped or untapped? Yep. Because a lot of times you'll have a splitter down the road or a splitter in the apartment because they have 2 TVs. So as long as you respect the up to 16 way split, you're fine.
Yeah, and note that speed, we're talking about 1 gig as our benchmark here, but with 100/20, you can see the curve is an asymptotic curve, so it can, you can go much further. That's
right.
Now, can you go a mile? Maybe not, but right there.
But again, we are not focused on the single family unit. There are some corner case applications where you have aerial cables that might be serving a small cluster of homes. Yeah, we could probably put our outdoor unit up there and serve those clusters, but that's a corner case. Really, we're well within the distance spec of offering a gig symmetrical in any building.
A lot of corners.
Yeah, and the point of this presentation is to make people aware there are other VDSL technologies that I'm sure many of you are aware of, but it's, the positron focuses on MDUs, but understand we're technology agnostic, but the solution here is something to be considered. It may be another provider that you look at for individual residential homes.
Right.
But to understand that this, the physics of this is what we're trying to do here.
Right. So essentially, the maximizing the fiber access by reusing the MDU wiring allows you to have a lot more cost saving, right? I mean, a lot of the projects for BEAD, you're allocated a certain amount of money. And if you take that money and you use the, I would say, conservative per door fee of running fiber of say $600 a door, okay? This is gonna cost you about $150 a door. So it gives you, and it gives you an idea of how cost effective this could be. Let's look at the products. So we do have, as I mentioned, both a coax and a copper version of the product. We make an indoor and an outdoor unit. The units are on the left, which are 19-inch rack mountable, are what we call our indoor units. So they're not, hardened or tempered for the outdoors. They're typically installed in a wiring closet or, somewhere in the basement. If it's the coax where all the coax terminates. We do have a 12 and a 24 port. They each come with 2 SFP plus cages that are good for up to 10 gigs. So you can have up to 20 gigs of backhaul broadband to each chassis, or 10 gigs that you could daisy chain between units if you had a large installation. The 12 or 24 port is, like I mentioned, the indoor unit. The outdoor unit is an IP68 clamshell. It'll do either 4 or 8 ports on copper, and we only make a 4-port coax because of the split ratio capability. You really almost never need more than a 4-port for different townhouse, garden home complexes, because they typically tend to be 8, 12, 16, rarely beyond 16. And with a single unit, you could actually serve 64 if you had to use the maximum split ratio. So it's almost like you almost never need an 8-port, but we do make a 4 and an 8 in the copper. And then we have the endpoints. So the endpoints, as I mentioned before, our GAMs basically have an 80 gigabit Ethernet switch fabric. So it is a gigabit Ethernet switch, but then we convert to G.hn on every port so that you can use that wiring. And you're going over the telephone wire or the coax on G.hn. On the other end, what you need to do is convert G.hn back to gate Ethernet to be able to connect to your residential gateway. And that's why you need that endpoint. So that's the catch. It's really a gigabit Ethernet switch, but you have an endpoint and you're using the telephone wire or the coax. And that endpoint comes in various flavors. We have it with 2 gig Ethernet ports so that you could do VLAN trunking, so that everybody in a particular project can get their own VLAN. They can be on their particular, plan wherever they go on any kind of, common areas. They can print to their printer. And then we also have them with the second gig Ethernet port, which has PoE capability, so you can power the residential gateway as well. We have the plain ones, we have coax, of course, and copper. And for the outdoor unit, we also provide it with a couple of powering options. You can have it locally powered with hardened AC power, or you can have it reverse powered. So you can have the outdoor unit bolted alongside maybe, the townhouse complex, because there is no common area to put any equipment and you don't have power outdoors. Well, then basically the endpoint with the CR, stands for reverse power, can power the unit outdoors. As more than one subscriber connects to the GAM, they share the power load. So it's not like somebody unplugs and they take down the network, right? Okay. Just an internal view, different mounting options for both the copper and coax version, strand mount, wall mount options for that. Many of our customers are Calix customers as well for the fiber. And it's either Calix, Adtran, or Nokia typically that we work with. What we've done with Calix is we've done OMCI integration, which is really popular because it basically means that you get to use the SMX platform, which is the uversion AXOS, to provision to the GAM as if you were provisioning a fiber customer. So we make this XGS-PON ONT, which is basically an ONT on a stick. That's designed to work with Calix so that if you plug that into our GAM just basically looks like a multi-port ONT. And that means that from a provisioning perspective, you don't have to do anything on the GAM. You don't need to learn the GAM software. You don't need to do anything on the GAM. You're basically provisioning a GAM subscriber as if it were a fiber subscriber. So this is really popular with, I would say, probably about 50% of our tier 2, tier 3s. There's multiple ways to actually work with the GAM. The larger operators, they typically will use our API and build, the provisioning right into their OSS, BSS, because that's how they like to work. The really small operators that don't even do this, they typically work with our user interface, and we also have our EMS called Virtuoso, which we'll show you in a minute. But a lot of the mid-market customers that do a lot of work with Calix or Adtran, they like this integrated provisioning because it makes their life easier. The technicians are already trained on this particular platform, and it makes it really easy for them to provision customers. A little more on that and the spec for how that's working. So as I mentioned before, there's really multiple ways that you can provide that backhaul broadband capability to the GAN. That could be either fiber to the building, and that could be any type of fiber. And that could be an SFP fiber for Ethernet. It could be a GPON, EPON, XGS-PON. We are coming out with an NG-PON 2 ONT on a stick to work with Calix in a couple of months. So any type of fiber technology or fixed wireless access. So we are partnered with Cambium, also with Serrana, which was Signal. And we've worked alongside Tarragon a couple of times, so we're open to that. But basically, the idea here is if I have line of sight today with millimeter wave, I can beam up to 10 gig, right? It's very common to do 2.5 or 5 gig, but I can go all the way up to 10 gig if I have line of sight to a property with a rooftop antenna. And then that rooftop antenna typically connects to a Juniper switch or a small Microtech switch, connects to our GAM. And again, I'm using the in-building wiring. So it becomes really easy to do this, especially with a point-to-multipoint radio and when I have line of sight. When I do not have line of sight, then of course it becomes a little more challenging. And maybe we will have a relationship with our friends at Starlink that could help solve that problem. Okay, so target markets, obviously MDU market is the biggest market. There are 20 million people living in MDUs. There are 20 million MDUs just in the United States with 5 or more living units. So that's about 25% of population live in MDUs. We know that from a value perspective, internet is 86% the most important amenity that a renter looks for. Having good broadband is going to provide your property with an 8% rental premium. It increases the value of your property, and the CapEx savings for you as a provider could be between 60 and 70%. So whether it's the older brownstones or garden home, townhouse types, they're both the types of MDUs that we typically work with. Another target market is strip malls, older kind of, hybrid commercial, residential type properties. Anything that is going to be a challenge to run new wiring becomes an option for the positron equipment. We've done a number of digital equity projects, a couple in Maryland, Project Waves. We have worked with Montgomery County on a few properties. We were very involved with a different technology for ACAM and CAF2. We helped, I would say, a couple million homes get 10 and 20 megabits back when they were not even able to get like a megabit. The problem was that their housing areas were oftentimes way outside of the serving area. So if they were beyond 10,000 feet from the closest central office, they were barely getting a meg. And we have and still have technology that allows them to get 10 and 20 megabits because they're line extenders. And that line extender was very popular with a lot of the same customers that we're working today to deliver that bandwidth. So many of the predecessors to BEAD, which was CAF2 and ACAM, we've done a lot of work with that.
Peter, we got another question in the chat.
Sure.
Yes, what does the customer premises equipment look like and how is it connected to the network?
So it's, I'm going to just jump back a couple slides. It's this right here. Oops. Didn't know it was that many slides. Okay, so it's an endpoint. It basically has a power supply and it connects your residential gateway in either the 1 or 2 gig Ethernet ports that are here. So this will sit typically alongside your access point. Most of our ISP customers will get these little enclosures to put the endpoint, the power plug, and just feed the, whether it's an Aruba or Ruckus access point. We can also power the access point, so that removes one power supply, but that's typically how our customers put this together.
Yeah, I think embedded in that question might be does it have integrated wireless or do you have to put a separate wireless unit?
No, we don't do the endpoint wireless. You have to use either your existing residential gateway or whatever your ISP customer will provide for the service.
Right, okay.
Now, typically, and I'm gonna say this very generally, we're not standing up for these vendors, but typically Ruckus, Aruba seem to be the two most popular endpoints that our customers use. They use it because it's part of an overall network and a server and everything that allows them to see when their customers are up and down, et cetera. One of the things that the endpoint allows us to do though, or allows our customers to do as well, though, is actually recycle the endpoint, which is often the problem, right? Just to kind of unplug the endpoint. The fact that we can turn it on and off and that we are powering the endpoint means that I can recycle them. Let's jump here. Okay, a really big market for positron is the whole hospitality space. So if you have older properties, which they typically are, Las Vegas is a big space for us. We do work with Caesars Entertainment. We are basically approved by Marriott, IHG, Hilton Hotels. We have a number of boutique hotels. We did the Nika Hotel in San Francisco and a bunch of others, both internationally and in North America. This is a really easy fit for hospitality because hospitality is a bulk deal, right? You're working with the actual, owner of the property, and they're going to do the same thing on all the rooms. Typically, what they'll do in a hotel environment is you have each rooms that typically the TVs are back to back. All right, so two adjoining rooms, the TVs are back to back. They're going to put one endpoint, one access point, two SSIDs, save a lot of money, and basically provide good broadband in the room. Now, the reason it's become such a big market for a company like Positron is up until, let's say, pre-COVID, right? Most people would go into their hotel rooms to do email, right? Most people were not doing WebEx meetings in their rooms, right? It became really popular after COVID. And getting that, full duplex speed in a room when your access point is in the hallway is not possible. Okay. And so you have to bring the equipment inside the room. So your access point has to be in the room. And to do that, you need to have access equipment like the positron to be able to give you that service in the room. And today, the casting, the multicasting, and the video calls are really popular in the hotels. And this is why, of course, most of them are upgrading to this technology. For them to upgrade using new wiring is very costly, right? And they're basically taking down a couple of floors at a time, out of service, loss of revenue. It's not something they want to do. They've got coax and copper in all those rooms. They all have telephones and they all have cable TV. So it becomes really easy to do. And this is actually a very easy space for positron.
There's a question here.
Sure.
So are you working with ISPs that are trying to serve the urban unserved areas? So there are these urban deserts throughout the country, primarily because low income people live in multi-unit.
Yeah, as a matter of fact, we have a customer that's in New York, and they serve the 5 boroughs and Brooklyn, the Bronx, and all of these areas. I mean, it's the where the equipment needs to go is like sometimes it's in the garbage chute. I mean, it's really like, and so yeah, there's really nothing good. And I would say 80% of those buildings are still on the old VDSL stuff.
Yeah.
And you could deliver a 500 a gig service over that same wiring. So yeah, we have customers that serve those markets. And I'm actually working on a pretty big project that's serving a bunch of buildings in Brooklyn. And a lot of these buildings are actually being kind of like decommissioned from Verizon because Verizon had to offer voice services up until a few years ago. And then it was postponed, but they kind of decommissioned that. They're kind of saying we're not going to offer voice services anymore. So it becomes a bit of a land grab for these smaller ISPs that want to offer a VoIP service, an over-the-top service, like we're going to talk about right now, and or a good broadband service at the same time. At the end of the day, it's really just about getting the broadband because you could offer voice, you could offer your over-the-top services, and that's what they're doing. Where today they're really just getting a VDSL or ADSL service with a phone line, and that's all they got.
Can I connect you to an organization that's like focused on like serving urban unserved areas with mostly people in these multi-dwelling units.
So the question is,
Can I connect you?
oh, yeah, that would be great, sure. This is an important slide because it has nothing to do with what we do, but you guys are probably familiar with this. Many of the properties that we go after, a lot of time they're seniors and, you know, they like their channel roll up, right? They're used to their channel 12 news and all of that good stuff. And then you come in and you want to offer them a broadband package. You would say, you don't need, you know, you don't need your legacy TV anymore. Like, no, don't take my TV channels away, right? And so today you've got so many options that provide the local channels, YouTube TV, Fubo, Sling, Hulu, all of them have these plans. And they're as low as $25 a month. And you could start offering them the local channels and the specialty channels and all the top over-the-top services over that existing internet. So it becomes a much easier sell to say, you don't need to use, and no one wants to pay, you know, Comcast or Charter for their TV channels and another $50 or $60 for better broadband, right? So if they can get rid of it, but at the same time still get their local channels, it becomes a really good option. Okay, let's look at a couple of ways that our technology works. When it comes to both telephone wire and coax, you typically have home runs. You typically have, whether it's cable from the apartment down to the basement, you will have structured wiring type. I say type because obviously the real structured wiring was when Cat 5 and Cat 4 came out. But the structured wiring of telephone is that you typically have an IDF in every floor and you have a BIX block and, you know, everything terminates there. And a lot of times all the equipment is in the basement, which makes it really easy. And we'll see why. If I'm doing a typical telephone wire installation, as an example, we're saying, okay, here's an MDU, fair size, mid-size MDU, 96 subscribers. I could have my either fiber or wireless, fixed wireless access broadband coming in to an SFP plus. I'm using the others to daisy chain 4 24-port units. So I've got 96 ports, and I'm using the Cat 3 or telephone wiring to an endpoint and an apartment. This is a basic installation for copper. If I'm working with more of a garden home townhouse setup, which we do a lot of times what you'll see is these maps of clusters of homes that are together. So you have 4, 6 units together, and you have, maybe sometimes 24 of these clusters, and that's a property. And a lot of times you don't have fiber to each one of the clusters. So that becomes a problem because you either have to get fiber to each of the clusters or millimeter wave or whatever it is to get that backhaul broadband. If you're looking at offering 100, 250 meg service, one of the things we can do is we can actually daisy chain the transport over the existing copper or coax. So that if you only had fiber coming into that first cluster, I can take a couple of ports on the GAN and turn them into transport ports as opposed to end user subscriber ports, and basically daisy chain my transport to the different locations without the need to run new fiber or millimeter wave to those other locations. So you're not going to do a gig symmetrical when you're doing this. You're going to basically use a gig port to do the transport, so you can easily deliver like 200 meg, 250 meg symmetrical, which is very acceptable for many of these projects. Looking at coax, so this is a pretty popular setup. This example could be another 100, so on 120 subscribers. I've got my backhaul on fiber or wireless, and my 24 port with, let's say, an 8-way splitter. So you've got a little pigtail on every port with an 8-way splitter, and all those home runs that come into the basement are connected to those splitters, and I'm serving 120 customers with just a single 24-port switch, as an example. And in this case, I'm using the 1002C plus endpoint. This one has the PoE capability, so it's also powering that access point. Same thing with the outdoor unit for coax and the ability to daisy chain the transport. And again, that's with or without the local or reverse power. The GAM has, as I mentioned, multiple ways that you can connect to it. JSON API. We also have a Swagger API built into our Virtuoso EMS. The product itself comes with its own UI. There's no charge for the actual user interface that comes with the product. And then you can also get our API if you wanted to use, or even the command line interface to use your own OSS and do your own integration. Virtuoso is an EMS that we actually sell, which is not necessary, but does provide alerts and alarms and the provisioning with the ability to see all of the GAM software capabilities, the service level agreements, the spectrum analyzer for diagnostics, the quality of services. I can set aside different bandwidths. I can notch certain spectrum out of a cable infrastructure because I'm doing whatever it is, a security camera or specific channels. I've got all kinds of capabilities. The software is pretty rich in terms of managing the bandwidth. And one of the nice things about the G.hn technology is you get to pick how much bandwidth you want to provide upstream or downstream. So unthrottled, you've got 100, you basically have a gig symmetrical for every port. So if I unthrottle you, you're going to get a gig or 940 megabits in each direction because you've got that overhead from Ethernet. Oh, interesting.
Lock on, yeah.
Well, good, but.
An outlet right there to plug in.
That's not mine. Yeah,
Humans would be.
it must be this one.
Okay, I'll plug it in.
Because mine is pretty good. Otherwise, they'd be really upset. You're supposed to have a really long battery like this.
Right. Yeah, plug in.
Yeah, power supply.
Yeah, there's one up here. Okay. Let's get it started.
Right, so just again, the capabilities of the broadband profile is really something that's flexible. I can then decide that I want to offer a symmetrical service or an asymmetrical service. I can offer a 100 meg service symmetrical, or I can offer 100 by 50, or 200 by 300, or 500 by 500. I have full flexibility in defining my packages, which makes it really easy if you're looking to upsell customers down the road. So if you wanted to offer a 100 meg package today and upsell them to a 200 or 500 or a gig package down the road, all it is a software setting. So the dashboard and the different capabilities of Virtuoso, which, as I mentioned, something that you don't need to run our service, but you can get as an extra, gives you the ability to do golden configurations, provision to all the GAMs, do firmware upgrades, get your alerts and alarms on a global kind of situation. So it's not just a property, it's multiple properties. It's actually becoming very popular. Okay, this is a slide most of our customers like to see. It's, how do we compare to that rewiring fee? Okay, so we try to take a kind of a conservative approach. This is information that we got back from some of our customers that if I had to rewire, say, 192 unit MDU, my cost for labor will be about $250 a door, and my cost of material will be about $350. So $600 a door is actually conservative for especially places like New York and Boston. It'll be much higher than that. I've seen it as high as like $1,200. But, and I've heard some customers say, hey, Peter, we can rewire for about $350. So I've heard both stories. 600 is kind of like somewhere in the middle. And, your labor and ONT costs would take you to about $130,000 to rewire a building of that size. Now, if I compare that with the cost of the hardware for a coax version of the product with a 4-way split, you're looking at $110 per door with labor of $50. You're coming in at about $37K for that same 192 unit complex. So it's about 25% of the cost, and it gives you an idea of what the cost saving could look like when you're working with this type of technology. I think I mentioned before, positron, I've been around since 1970, so it's almost 54 years in July. So in July, the company will be turning 54. We've gotten a couple of awards on this technology. The company's had a lot of successful exits with fiber, VoIP, 911 services. And this is probably one of the biggest product lines from the CEO's perspective. The same CEO runs the company today, and is very exciting, a very exciting time for positron. That's pretty much it. So I can take more questions now, and I will also leave you some of my business cards if you guys want to find out a little more about the products and where you can get the product. We do have distributors across the US and Canada that carry our products. So you can get
Yeah, one question though, how do you comply with the Build America, Buy America standards?
So we do comply to BABA because we are 100% of our equipment is built right in Montreal. And there's a lot of I can't remember what the name of it is, but there are clauses in the BABA that if you have certain things that are built in Canada and countries that are friendly with the United States, you kind of comply. And we basically do not have an issue with that.
Any other questions? So again, I encourage you to look at, this was specifically about multi-dwelling units, but I encourage you to look at other solutions for the physics is the same. You know, when you look at bandwidth, the limitations are related to the inductive reactance of the cable you're using, which limits the bandwidth. So, you know, there are others. So the physics of this solution is the physics of all copper solutions. They're just following the physics of twisted pair, the physics of coax. And of course, that also defines why we're focusing on fiber, because this inductive reactance is the limitations that affects all these technologies.
One thing I'd like to add is today we are doing a gig symmetrical, which, like I said, because of the overhead on a speed test, you're going to see 940 meg in each direction. But we are coming out with a 2.5 gig PHY on our endpoints, so you can actually get 1.3 gig in each direction. So that means that if you need to, comply to a gig for business services, you'll be able to offer a gig SLA. So you do have that capability, and this is it's an upgrade to the endpoint, basically, because the 2.5 gig PHY is already in all of our GAMs, all of our chassis. It's just the endpoint had a 1 gig PHY, and now we're upgrading them to a 2.5 gig PHY so they can get 1.3 gigs in each direction.
Yeah, and to even get further down on the physics of this, and it really ties to our next presentation as well. All the limitations, basically the formula is your bit rate is equal to your bandwidth times log2 of signal over noise. So the point being bandwidth in copper and coax is limited by the inductive reactance. And the key points are how much bandwidth can you get on whatever transport medium you're having, and how low can you get the noise? And that's really determines what you get for a bit rate. So, you know, the caveat is every situation is different. But, you know, generally what you're looking at is these kind of speeds.
Okay.
Okay, our next presenter is Dirk Gates from Toronto Wireless, and I'll make a point that, you know, Dirk will talk about the different technologies that are used in order to optimize wireless. You know, we look at the challenges of wireless in Vermont. You know, we've got a lot of hills. It's funny, when I went out, saw the demo out in Lake Tahoe, you know, their mountains are different than our mountains. You know, you can put something on a hill and get a long range, where we have a lot more of this. That's funny, when I was flying back from South Lake, look at our terrain, I'm like, oh, I can understand why our challenge is different than the Sierras. But not to say it's not a solution, just saying it's a solution that they've optimized. And there's other, I think I saw a presentation from another company that I think is doing the same thing, but you can talk about the differences between different companies. but using waveguides and using multipath. I'm particularly impressed about their sampling rates, but take it away, Dirk.
Thank you, Christine. Dirk Cates, joined Toronto Wireless about 2.5 years ago as president. And my primary focus has been on customer experience, trying to make sure our customers, which are service providers using our equipment, are getting everything they can out of it. What's interesting is today, we first heard about a solution that works for very sparse locations. What'd she say about the pepper flakes? Was that the analogy? Okay. And we just heard something about a solution for dense locations where you've got fiber in the right place, but you've got to get it to a lot of other little places. We're in the middle. We're sort of a suburban rural solution for when it's too costly to get fiber to the residents. You got to cover that last mile or last 5 miles wirelessly. We have a point to multi-point wireless solution that's gig capable and provides that capability. So it's really, this is going to be another tool in the toolbox for us closing the digital divide and finding a way to serve everyone. Let me give you a little bit of background on the company and what we're doing. So this company was started 15 years ago by 4 different PhD students at UC Berkeley. They were all actually international students. They were doing their project or their final project, trying to figure out how to close the digital divide in Ghana. And they were looking at various wireless technologies to do that, and were disappointed that anything they could find off the shelf at that point wasn't going to do the job right. So they came up with an idea for a new RF physical layer, got an A on their project, graduated, started a company. What else do you do in Silicon Valley? So now here we are 15 years later. It took about 10 years of prototyping and developing this RF physical layer. First deployed point to point with very expensive FPGA technology on both sides. It's still actually in use by a lot of the major carriers. AT&T, Verizon, T-Mo have point to point links operating in unlicensed spectrum, backhauling licensed cellular. That's how good the technology was. The trick was to bring the cost down. So then they spent probably a good 4 years committing that to silicon, building their own chipset. It includes an SoC, their own A to D converters, our own RFIC to be able to make the endpoints cheap enough to do point to multi-point. And so that product launched just over 2 years ago. Now in use by, it says 200, and actually 300 operators using it. And so a lot of industry firsts. So what does it offer you? You get fiber class speeds anywhere from 100 megabits up to gigabit. And you can do that high capacity. Each base station, what we call a base node, supports 256 users. With 4 of them on a tower, you can support 1,000 households. And it works non-line of sight. We'll go into a little more about how that works. But that's important because you look at the US, maybe 20% of the residences in the US have direct line of sight to some vertical asset. 80% do not. So, and the other key solution here was figuring out how to make this technology reliable in unlicensed spectrum. And we'll talk about how we managed to do that as well. So let's just dive right into the product. So what are we offering? So our first generation product we call Gigabit 1, G1. It consists of 2 different devices. One is a base node that sits on a tower. That's the center picture here. It's about the size of a small suitcase, weighs less than 50 pounds. It's all self-contained. And in fact, that just needs to be fiber fed or microwave backhaul fed. Can take up to a 10 gig input. Each sector, each base node has a capacity of 2.5 gigabits per second that they can supply to those subscribers. The subscriber unit, the CPE, is the size of a small college textbook, sits on the side of a house. What's interesting is we can use frequency reuse of 1. So you don't have to have different carrier frequencies for each sector, different carrier frequencies for each site as well. The product is offered in multiple flavors. We support 3 gigahertz operation CBRS. support 5 and 6 gigahertz as well. There's a 5 gigahertz product. The initial one was Uni 1 and Uni 3. And the new 6 gigahertz product is Uni 3, 5, and 7. So we have all of that. And all of this is managed by a suite of cloud utilities, APIs you can use for configuration, but also just cloud managed from anywhere. So very simple architecture. It's basically, it's a layer 2 solution that you feed into your whatever router you have in your network, and away you go. So a little more detail on the base node. We talked about 3 different flavors in terms of being CBRS, 5 gigahertz at Uni 1 and Uni 3 also supports Uni 4 now, and 6 gigahertz likewise. In terms of capacity per link, in the 3 and 5 gigahertz device, you get 800 megabits per link, and you can split that uplink, downlink any way you like. Typically, it's 1.5 to 1. So you do like 640 down, 120 up kind of number, but you can do symmetrical, 400 symmetrical if you'd like. The 6 gigahertz product is capable of operating with 4 carriers. The 2 other products are 2 40 megahertz carriers that are aggregated to give you the 800 megabits per second. The 6 gigahertz product can actually use 4 carriers, 4 40 megahertz carriers, aggregate those up. It has a link capacity of 1.6 gigabits per link. And that can be gig down, 500 up wirelessly. And if you take a look at user count and capacity, so I mentioned 2.5 gigabit capacity per base node. That's for the CBRS and the 5 gigahertz. You actually get 3.2 gigabits of capacity per base node. 6 gigahertz, which means per cell with 4 in a tower, you're up to almost 13 gigabits of capacity in that particular case. All right.
Quick question, the CBRS and the Uni 3 are different products, I presume.
Yes.
Okay, 2 different products.
And then the CPE, the subscriber node, what we call the remote node, if you look at it there, it's a typical installation. Different network profiles, like I said, the probably most popular was the 4.5 down, 1 up, but you have different versions of those profiles. This device in a line of sight setting can do 30 kilometers. So that gets you out, and I gotta do that. I've seen people doing the math here as well. What's that like? 10,
18.
yeah, 10, well, no, I'm actually doing the math and being too conservative. Yeah,
18
probably
miles.
15, 18 miles.
Yeah.
Non-line of sight, 5 kilometers. So you get about 3 miles out, non-line of sight. And we'll talk about how we do that here in a second. We also have what we call advanced I've heard as asynchronous burst interference cancellation. We'll talk about how that works. Got a question?
Your range estimates are based on the 3 gigahertz, I assume?
Yes, those are 3 gig. The 5 gig is similar, but really depends on interference in the area. So with 5 gigahertz, if you've got a lot of other 5 gigahertz use, maybe lower range. 6 gigahertz has very similar range because it's generally very clean spectrum. So, and the basically both the base node as well as the remote node have about a 90-degree aperture of what they can see, and they electronically steer through that. So in the remote node case, doesn't have to be aligned accurately. You just get it on the side of the house that's pointed roughly in the direction of the tower, and it'll electrically steer itself and align to the base node.
Sorry, just one model for the subscriber unit?
No, there's a CBRS version, there's a 5
Sorry, in
gigahertz,
terms of gain. In terms of gain, antenna gain.
just one. Yep. And then devices powered PoE, 2.3 BT, so it's 35 watts of power, a simple installation. So let's talk about what this looks like in the real world. And hopefully you guys can see this is miles on the horizontal axis. And then on the vertical axis are speeds. And this was a sampling last year of 50,000 live connections across our various operators, and they've deployed this. The darker bars are the 3 GHz performance. And as you can see, out to, let me walk over here, out to 3 miles, you're still around 500 megabits average link speed capable on the device with the 3 GHz, about 400 megabits on the 5 GHz. These bars are one standard deviation, so mileage will vary depending on terrain, but still getting out at 10 miles, getting an average that's just under 400 megabits with the CBRS gear, and an average that's still over 200 megabits with the 5 GHz gear. So that's what that looks like. And then if you look at this down here, just tells you sort of the number of links we have at each day. So quite a few here, but we do have a reasonable number out at the 10 mile. So that's what the gear is.
So is that the number of links supported, for the distance covered, or?
No, this is the number of links deployed. In this 50,000 sample.
Oh,
The number that were deployed at those various distances. So. And I think you can see that there were, CBRS, well, there's probably a similar number of very long distance 5 and 3, but you can see that the CBRS sort of skews to the longer distances. And wanted to point out that the current CBRS product, which is well capable of the 100 by 20, is a BEAD qualified product. It meets the NOFO's definition of reliable, is both the GAA, generally available access, as well as the PAL, the priority access license in CBRS are considered licensed technologies. So this product operating CBRS is a licensed, reliable product. So this is your BEAD product today. That being said, the newest product that we find most exciting is the 6 GHz version of the product. Operates in 4 carrier mode, and it allows up to 1.6 gigabits per link and 3.2 gigabits total per sector. This is what we call in an X2 mode. We took the existing product, which had originally been designed for 2 carriers and 4 MIMO streams, but as in reality, when you get to outside, you're really only good for about 2 MIMO streams, horizontal, vertical polarization. And so the product, basically, we turned off 2 of those streams. We had 2 carriers, 2 streams, but the whole thing had been designed silicon level all the way up to the software. 2 carriers, 4 streams. Instead, we changed it to 4 carriers, 2 streams. We were able to turn on 2 more carriers. It's a neat little software trick that allowed us to double the capacity of the product. And so when you look at what's available in 6 gigahertz, there's a ton of spectrum up there, quite a few channels. But one of the interesting challenges, what's different between what we're doing and what most of the other fixed wireless equipment that's based on Wi-Fi technology is doing, is we're able to use any combination of 40 megahertz carriers. So depending on what the AFC, the Automated Frequency Coordination System, returns as available spectrum, we can pick the highest power set of carriers. Equipment based on Wi-Fi today requires a contiguous 160 megahertz wide channel, and there are only 4 of them. And if you look at what's available through the AFC, you'll find that depending on your setting, in rural settings versus urban settings, only about 30% of the towers, we did a complete survey of all of the available towers that can be leased on in the US. Only about 30% of them in a rural setting had full power available on a 160 megahertz wide carrier. So very frequent use of microwave backhaul in 6 gigahertz throughout the US, which cuts down on the power available for other users of 6 gigahertz. Now, if we change this to 40 megahertz channels and being able to assemble 160 megahertz using multiple 40 megahertz channels, suddenly that number jumps up to 76% of these tower locations throughout rural areas had 4 available full power 40 megahertz carriers. So very important to have the multi-carrier capability. And then talking about coverage. I don't know if you guys can see this. But when you're operating in the gigabit mode and you have line of sight, you line of sight out to about 16 miles at 200 megabits, you can get line of sight out to about 7 miles at 500 megabits and out to just over 3 miles at a gigabit and 6 gigahertz. And then if you're non-line of sight, it's about a mile to 200 megabits, about a half mile to a gigabit. So those are your coverage. And then if you look at, CBRS is insane. You can do 200, actually 500 megabits out to 20 miles. You can do non-line of sight, 500 megabits out to about a mile. So, in this area, CBRS would be a great option. Works well, non-line of sight, speed compliant. We sort of what are you looking at? So let's go through a little more on the technology. So let's first little definition of what we're talking about. Line of sight is pretty obvious. You have a direct sight. You can see the tower from the side of the house. There's nothing in your first Fresnel zone. And your path loss ends up being very close to what we just calculated as free space path loss. What we call near line of sight, there are objects in the first Fresnel zone, but not in the line of sight. So you're slightly obstructed, but you're not fully obstructed. Non-line of sight, there is no full line of sight. You're blocked, and your path loss here is typically 15 dB or greater than what would you have with a calculated free space path loss. And so that's what we call non-line of sight. So legacy fixed wireless, what people have used traditionally for fixed wireless, has really been optimized for line of sight. On the other hand, what we built was optimized for non-line of sight.
I have a question.
Yes.
So this diagram is typical of what you see in a suburban setting where you have a high tower and a house below that. I think a number of the extremely high cost per location threshold locations we're gonna have in BEAD are the opposite, where they're up in mountains and there's no poles to get there. So can you talk to that? Like, it
works either way if you, as long as basically, this diagram you said is very typical, but it really depends on just whether or not the path from the home to whatever from receiver to transmitter, whether it's blocked or not.
Yeah.
And so in our case, so if you've got something where you've got.
Because there is an angle too high, right? So I mean, if the house
The
is,
question really,
yeah.
it really is, how many feet of trees can where you lose 15 dB?
Actually,
I mean, because we've got very long shots. Sometimes we have CBRS and we're doing better than this.
I was talking about the angle, yeah, the amount.
We can go through it.
Yeah.
Current CBRS.
no, CBRS definitely goes through trees quite nicely.
Yeah, well, a good signal to noise ratio.
So it's, well, it depends, but.
But back to your question now, do you have a sense of what loss is? 15 dB is how many feet of, I mean, obviously it depends on the pole.
Well, I was saying that, so we actually work at path loss. So if you look at your path loss, this was a differential between free space to, I'm saying anything 15 dB higher, we call non-line of sight. We'll operate with path loss from transmitter receiver up to 160 dB. So you're depending on distance, depending on other obstructions.
But you're differentiating your equipment that runs in CBRS versus other equipment providers.
Yes.
correct? So I used to work Microsoft's Airbnb initiative, and I used to work with a number of people that use a number of ISPs that use your equipment. And what you're saying is exactly what they say. It is superior as far as line of sight, as well as the speeds that you receive.
So typically, other fixed wireless technologies have been based on mobile technologies, either Wi-Fi, adapted to work outdoors, or 3GPP. trying to use that. And both of those technologies were designed first and foremost for mobility. A lot of power, a lot of compute capability in the base station, but designed to talk to something that's small, battery operated, small antennas. So you end up with, massive MIMO, and their definition is 64 antennas in the base station and 1 or 2 antennas in the handset. Our technology is more distributed massive MIMO. We've got 16 antennas in the base station, 8 antennas on the side of the house. And because we have that capability on both ends, both in compute and in spatial awareness due to the size of the antenna array, we're able to do better steering, better beam forming, better null forming, better noise cancellation on both ends of the link, so you get a more symmetrical link.
In a prior slide, you mentioned 76% of towers are qualified to do work in rural nationwide. Do you have any idea how that translates into the qualified towers in Vermont in terms of the percentage of rural Vermont that could possibly even be covered by this?
That particular slide is talking about 6 gigahertz spectrum availability.
Fine.
And in 6 gigahertz spectrum availability, it's basically a function of how much incumbent 6 gigahertz microwave backhaul exists in the area. And I don't know how that works in Vermont. I don't know if someone knows what that is, but I can easily look that up.
Yeah,
But
sorry, I have a related question once you finish.
so that was really a specific to 6 gigahertz spectrum and specific to incumbent 6 gigahertz microwave backhaul use. And those were general numbers across the nation. You actually in rural settings, typically you'll see more backhaul usage. That's why that number is lower than you see in the urban settings.
But if you've got fiber feed to the tower, that'd be.
Right. And then you don't have the microwave backhaul.
So that's all you need is fiber to the tower and then the tower qualifies for what you're saying? Is that what you're saying?
So let me back up the slide. Let's go through it again. This was a discussion of what spectrum was available in terms of, so with 6 gigahertz usage, unlicensed, you go through what's called an automatic frequency coordination. So each transmitter has to go through a cloud-based system. Federated Wireless runs one, ComSearch runs one, and that system has a database of all the existing 6 gigahertz microwave backhauls in the country. And the number one function of the AFC is to protect those incumbents. So if they're using a particular frequency, then you're told as an unlicensed user of the spectrum, you can't go, you basically have to reduce your power or you won't have any power at all at that frequency. And so the question is, how much of that spectrum, even though there's a ton of it, how much of it is really available by setting throughout the US? And in this case,
I understand that.
right. And so what I was,
And it's likely that we have more available than other parts of the country, yeah.
and so the point on
That's
these
my
two slides,
question is,
Yeah.
how
Point-
valuable is this to those of us who are planning to roll out into the rural parts that have not been served today?
Probably one of those AFC providers should answer that question.
right? So if you want to start looking at gig service in rural settings, this is the spectrum to do that. I mean, that's beyond BEAD, but this is the spectrum to do that. And the point of this slide was Wi-Fi based equipment requires 160 megahertz channels, and very few of those are available because you're going to run into an incumbent somewhere. Our particular device, by using 4 independent 40 megahertz carriers, ends up with a lot more ability to find that spectrum at full power in 6 gigahertz. And that'll be true in Vermont as well as other places.
Yeah, and if we're looking at under unserved areas, more likely that spectrum's gonna be available.
Right.
Yeah.
And so it's, what I suspect there are not very many incumbent 6 gigahertz backhaul flying around. I may be wrong.
So my follow-up question related back to that angle on that other slide, because I
Yeah.
mean, that's showing like maybe a 10 to 15 degree angle. But if you have a tower, which is here, you have a house, which is 45 degrees up here, that's gonna be too high, I imagine, because this was engineered for a typical use case.
This is very conceptual drawing. we've got guys with BNs on towers that are a couple hundred meters, like 700-foot towers out in Missouri. We've got other people that have put towers. The one you saw out in Nevada, that was, well, it wasn't much of a tower, but it was on
Yeah.
top of a hill and shooting into valleys. And so, and the angle is not really an issue. I mean, there's some steerability, but you can also, you can angle both the B and R and you can point them and look at the tilt as well.
That's helpful, because one of our concerns is the towers are low, we don't have a lot of towers that's really on hills and mountains around
Yep.
here. So that angle. could
And
be-
you'll pick the tilts on
Yeah.
both ends of the equipment to do that. So if you end up, if actually your towers end up lower than people up in the mountains, you can angle the BN up, you can angle the RNs down, so.
Yeah, and to make it clear that we're not, we're not saying these transmitters need to be limited to a tower, right? You put,
No.
yeah, and so, so my point is, if you've got a fiber feed, you could probably put them anywhere. You can put them on a bar in a silo. Right, right.
Depends on.
All right.
I think that's really the big concern, yeah.
So one of the key differentiators of our technology, one of the things we focused on was non-line of sight capability through multipath reconstruction. So when you're in suburban and urban environments, you end up getting lots of different paths from transmitter to receiver based on reflections and refractions over devices. And that's where that antenna array becomes important, to have the spatial awareness of where's the energy coming from and where can I send it back to. And it's not always a single beam. Sometimes it's multiple beams, and you can be able to reconstruct those and basically line things up. So, you know, a typical example here, you've got a base node, and I've got actually in this particular case, 3 very strong paths from base node to remote node as things are bouncing off of buildings, refracting over buildings. And on both ends of this link, we have the antenna array that allows us to understand where those beams are coming from and create an antenna pattern in the digital domain that matches that. And we use what we call autoconvergent retrodirective beamforming. A lot of words, let me explain what that means. So if I'm receiving energy from multiple directions on this end, when I go to transmit, I send it back in the same direction. Likewise, on the other side, I do the same thing. And so over a couple of frames, those devices will automatically converge to have the same antenna pattern, sending the same energy in the same direction that they received it from. The beamforming automatically converges to do that. And that's the critical part to making things non-line of sight. It's taking advantage of all of these reflections and refractions to be able to reassemble your signal. So the other thing that's important is being able to also steer nulls. Basically, the area where you don't want to hear energy from. And so you think about this, step one is, first of all, you don't want to interfere with yourself. So if I've got 2 different base nodes, I can put a deep null in the direction of the remote nodes that are talking to the other base node. I could even, if these were in fact pointed at each other, I could put a deep null in the direction of the other base node itself. And so by doing this, by being able to have these steerable nulls, I'm able to reuse the same frequency in every base station on a tower, and even towers that are pointed at each other. So that's important. So with the base node itself, we're able to have 8 deep nulls, 40, 50 dB deep nulls that can be steered electronically to be able to avoid our own self-interference and also interference from some other equipment on the same tower or nearby tower on the same frequency. And the remote nodes themselves have 4 deep nulls that can be steered. So that'll allow interference cancellation from local devices as well as our self-interference avoidance from our own devices.
And I assume that reduces your noise on the signal to noise ratio.
Quite a bit. Yeah, we're able to
Go back.
Just,
So do the radios automatically cancel out nulls, or do we have to
No,
calculate?
it's all automatic.
Yes.
So in fact, That's also part of what we call this a asynchronous burst interference cancellation. So what's happening here, think about those nulls. That's actually, that antenna pattern is being calculated in the digital domain 5,000 times a second. So every 200 microseconds. So very, every symbol length, essentially, that antenna pattern is being recalculated. We have a 5 millisecond frame, so within the frame itself, the pattern is being updated. That allows us to do a couple of things. First of all, if there are local interferers, someone has Wi-Fi, and you can imagine with the remote node on the house in 5 gigahertz, that's going to be the case. With a 200 microsecond update, we're able to change the position of that null to null out bursty Wi-Fi interference locally. That's key. The other thing this allows you to do is if anything in the environment is moving, trucks going by, leaves blowing in the wind, someone puts up the garage door, or puts down the garage door, that pattern is being recalculated 5,000 times a second. So and the beam-forming solution is being updated, and the null forming solution is being updated to take care of that noise.
And on that garage door example, the null points to the garage door.
Right.
Yeah.
Or if I'm getting a reflection off the garage door, I'll take advantage of that.
Yeah, right.
I'll update my beam-forming solution, I'll take advantage of that strong reflection off the door to help me get better signal quality. So. Let's see, here's an example, might be a little hard to see back there, but we have a demo that we do. In this particular case, we have the multi-path integrations turned off, and which is basically the beam forming solution, and we have the interference cancellation turned off. And this is a heavy interference. This is basically, we'll throw 8 laptops and a couple of access points around the remote node, the CPE, and have them running iPerf and just generating a ton of noise in the same spectrum that the device is operating in. And what you'll see is this is very typical of standard wireless solutions. I can get maybe 80 megs down, 30 megs up in this case. I've got a horrible constellation. I'm using very low point modulation, probably BPSK. Because I've got to do that to be able to get past the interference that I'm creating. And on the same example, as soon as I turn on the multi-path integration, start taking advantage of reflections and refractions to get a stronger signal strength, we've got a much better constellation. It's like I might be able to be at QPSK 64 or so, I don't know, 16 at least. Now I'm at 200 megabits. 80 megabits, but I'm still getting a lot of interference from these Wi-Fi interferers. And
These are your signaling rates, right? These are your signaling rates or your throughput rates?
so this up here, this is the actual, that's actual throughput. Throughput rates. Then turning on the interference cancellation as well. Now I can get to 64 QAM, 500 down, 125 up. So that's those two technologies, the beam forming, the multipath integration, as we call it, and the asynchronous burst interference cancellation are very important to us getting to these sorts of throughputs. So, kind of summary on the technology side of things. So key challenges that fixed wireless has faced in the past, dealing with obstructions, dealing with interference and unlicensed bands, dealing with throughput and link reliability, all these things. These are things that the Toronto G1 solution solves. Working well, non-line of sight, near line of sight, and line of sight. Very different. In fact, we like to call what we're doing is next generation fixed wireless access to differentiate. Because I always tell people FWA now stands for your father's wireless access. And so this is next generation wireless access. So some of the things that are really key is the ability to use unlicensed spectrum. Makes it a lot more affordable to deploy. Being able to have a channel reuse of one. So I can use the same same exact channels on all 4 base stations, all 4 sectors on a tower. And time to market is something that's significantly faster than other technologies. I mean, it's almost not fair to compare to fiber. It's like 1/10 the time to deploy compared to trenching fiber. And in many cases, it's 1/10 the cost. Certainly as you get out into rural areas, it's a lot more affordable to deploy. So let me walk you through a few case studies here. This is Whisper Internet out in the Midwest. They're in 5 or 6 states. They actually started deploying, they're one of our earliest customers. They were deploying CBRS primarily, but also 5 gigahertz. And they went from just a handful, their very first pilot installations, to thousands of subscribers in just a couple of months. And they're now, those I think those are actually out of date. I think they're over 10,000 subscribers on our equipment. And they've got 1,500 base nodes sitting on towers, probably that's like 200-300 towers, 300-400 towers. So they've been able to deploy this, and this has been under 2 years for them. So getting to 10,000 subscribers on our equipment and 1,500 base stations up and running in under 2 years. And they continue to grow. And they're most heavily loaded sector. They've got 128 subscribers on one sector, but they have many sectors with more than 100 subscribers. And so we've got other customers that have got over 200 subscribers on the sector. And that's a very typical thing. So what's interesting is across this entire population, the average download speed that they were capable of was nearly 500 megabits per second. So that's not what they're very frequently selling 100 megabit packages, 200 megabit packages, but the links themselves are capable of the 500 megabits. And what's interesting is we frequently encourage people as they deploy that when you configure an RN, don't stop when you hit the SLA that's been sold to the customer. If you can get 100 megabits, actually try to do a better job pointing and tuning it up, because if you can get 400 or 500 megabit capable, you're actually adding capacity to the sector. So it's an important thing. So that's why, even though I think the majority of what they're selling are 100 megabit packages, the majority of the links, the average link length, the link capability is 500 megabits. Because they've really been installing it with an eye toward capacity in the future. So
You got more airtime available.
yep, you use higher modulation schemes, just get more capacity overall. So, and 85% of the links that they've deployed are near or non-line of sight. So that was a breakthrough. They had traditionally been using Wi-Fi based technology prior to this that required line of sight. And they have quite a few very tall towers to try to make sure they can get that line of sight. Now they're able to operate non-line of sight. So another example, this is up in Northern California. Digital Path, another wireless service provider, they received a $400,000 grant from the state of California to basically they were tasked with providing service to 277 households with a $415,000. They did that and more. So they've been able to, they're now passing that budget allowed them to put up towers that now pass 6,000 rural homes and providing the service to those 277 households. And their average download speed for all the households in they're covering is 300 megabits with 70 megabits up. So if I take a look We'll have a meeting.
Those houses considered non-line of sight?
Hang on a second. See if I can figure out how to get back in the meeting.
I'm trying to figure out how this works in my town, that's what I'm thinking.
Yeah, picture's probably not a good match to the statement, but yeah. That's pretty funny.
All right, I guess I can see them. Well, that was a meeting. So you just see that. It's telling me I don't have internet.
Oh, you don't have internet?
Well, I'm on the guest network. Let me close Teams and the open.
You're an alternate.
If they do for it, they need to clean this, yeah. Do that.
The internet seems to be. Let's see if I switch to my. Let's go off the phone, see if that works better. All right, I'm back in the meeting. Sharing.
You want an alternate network?
I just jumped on my hotspot, so that should.
Yeah, that's where I was going. Yeah, just keep my hotspot.
All right,
There you go.
and we're back. There we go. So this is a network diagram. So I think the picture you guys saw of the tower was probably in this area, but you'll notice that this is some very interesting terrain as well that's being covered by a handful of towers. And this gives you an idea for the service that's available. 20% of the households could have service greater than 400 megabits, and only a very few percent were less than 50. So you have fairly interesting distribution of speeds available. This is all 5 gigahertz, by the way. This is unlicensed 5 gigahertz spectrum. And longest link in this particular case was 11 miles off of this tower. But you can see that in terms of what could support, more than 70% were greater than 200 megabits download, 93% of the 100, and very few support calls. So the nice thing about it is that the technology is very reliable. So Jim and the crew there is very happy about that.
Yep.
So let's talk a little bit about economics, and I'm going to be comparing to other wireless technologies. First, you take a look at this. If I were to try to build a network, 1,600 subscribers, and the coverage area of 20 square kilometers. I do this with Wi-Fi based technology. I end up with very few subscribers per sector. Wi-Fi is not good at loading up subscribers on a sector. The basic underlying medium sharing technology of Wi-Fi, the CSMA-CA, doesn't do well when you load it to 30, 40 subscribers. It becomes its own worst enemy in terms of gaining access to the medium and creating interference. And so because of that low subscriber count, per access point in in a Wi-Fi based solution, I've got to have quite a few more towers. And I can't offer the same level of service. So this is just based on, comparisons to other,
Good question. You're talking, this is 5 gig, 6 gig, right?
this is 5 gig, 6 gig, right, on Wi-Fi based equipment. Different comparison if I'm gonna look at a CBRS, LT or 3GPP deployment. So. And then if I took a look at sort of how this plays out in different settings and what's your cost, the key number here is if you take a look at how many households are passed per tower and what does it cost me to put base stations up on a tower? My cost per house passed is in single digit dollars. So you guys coming from a fiber world, that seems pretty foreign. That's a tenth or less, probably more than less than a tenth of the cost of a household passed when you're running fiber. And we've got folks that are offering packages as low as $49 up to $70 or more. We might have some guys in rural areas that might be a little higher than that, but this is very typical for the operators who are using our equipment.
What's their major expense?
Major expense? So there's probably.
What's one of the cost drivers on the?
Right, so the towers are part of it, but I think in ongoing, it's the cost of doing the truck roll to get out to the residents and getting the CPE installed.
What are the power requirements of the base stations?
Base station is about 300 watts.
It's in the home.
So,
That's a
Base
ton.
station
I
on the
think-
tower.
What's the home name?
so if you got upfront tower costs, but on an ongoing basis, I think that, we can do math together here. The
Well,
base station,
I mean, otherwise, you're comparing other wireless, they're all have the same towers. But what our costs are, and I just wonder how that compares with the maintenance operation. Running the trucks out for a trouble call is an issue, but presumably we've got resilient setup and they set up the first time and that's it. That's our.
No, fair enough. So
A tower sounds suspicious to me because of the topography we face in my town. So, I'm not quite convinced about that obstacle thing.
Well,
Yeah,
that's right, and that's.
It's easily, it's gonna require a number more, they don't have to be on towers, I understand, but they have to be frequently positioned in that.
That's
to get everybody-
not an unusual reaction to the description of the technology. The best thing I can do is put you in touch with other folks that have nasty topography and have learned that they can go farther and do more with Tirana than they have been able to do with other technologies,
With our wires.
other wireless technologies.
Right on the wires.
Yeah, and I'm an old physically entirely convinced about the technology. It's the obstacle.
Right.
Issue.
Reflection.
Reflection. And the reason we had AM radios going everywhere is because they got a big wavelength, a lower frequency, and the higher you get the frequencies, the shorter the wavelength.
Yep.
You can't fight that physical principle. And the shorter the wavelength, the more difficult it is to go around obstacle. Unless you get down to X-rays.
The difference being the amount of effort we put into the multipath reconstruction.
Yeah.
That actually makes it, that makes obstacles. And that, in the past, multipath has been your enemy. You get multipath showing up at the same location, out of phase,
Yeah,
at a time. It's
I'm with
destructive.
you, I'm with you.
Right.
And there's more multifamily in an urban setting or suburban than there is in the rural areas too.
It's like the mesh net approach. Good news, bad news.
So that was gonna be my question. Kind of multipath we have here through forest is really different than what's bouncing off of buildings. It doesn't behave the way most of what your examples are.
Can refract over trees. Pass through. So we've got deployments in some heavily forested areas up in Maine and in California. And so, and it works well there as well.
So just quick, I don't know if you mentioned, what's your typical pricing on the base station?
So the base station is, I'm gonna say $12,000 for a base station. And CPE is around $500.
Okay, thank you.
Yeah. So you got what, a $45,000 investment in the tower. All right.
And CBRS was that 5 gig?
But CBRS is a little higher. It's like, I said, 11 to 12. So
Okay.
CBRS is the high end of that and 5 gigs in the low end of that.
Thank you.
Does your CBRS offering package a SaaS? Or do we have to give it independent SaaS?
So you have we support both Federated and Google for SaaS. You have to have a relationship with a SaaS provider and just, you pick one or the other. If you have a direct relationship with a SaaS provider. 6 gigahertz, we bundle ComSearch's AFC with the product free of charge. We also support Federated's AFC. So if you want to use Federated's, there's a toggle in the cloud management. But ComSearch is bundled out of the gate. So a little more on the economics in terms of a couple of different operators that are using our equipment and what it's cost per location passed, sort of what they've been able to accomplish. So one last sort of exclamation point on cost of fiber. So we did a study here. This is a county in Idaho with 18,000 locations that need to be served. And we looked at cost of fiber deployments, not out of the cost quest model or anything, but this is pulled from information from 3 different states. It was California, one in the Midwest and one on the East Coast, Virginia on the East Coast. These were state-funded fiber projects based on household density, what they paid per household served. And yes, California has actually paid over $100,000 in state-funded fiber projects to pass houses. It's insane. So this is where this curve comes from. And we looked at the cost of figuring out how much it would cost to fiber up this county in Idaho, which is very rural, versus the cost of doing it wirelessly. So this ended up being, this would take $460 million to cover these 18,000 households, about $24,000 per location served. Fiber. They do the same thing with a study, basically saying I could put base nodes on 18 existing towers. I'd have to build 22 new towers. This could be factored into the cost. And when it's all said and done, I could cover wirelessly this entire area at $47 million. That's $2,500 per location served. That's 1/10 the cost of fiber. So when you guys are having your extremely high cost location threshold, it's going to get interesting. Fiber is going to get to a point when you make that cutoff, and then when you jump to an alternate technology, it's going to come down by an order of magnitude. It's going to be an interesting way to figure out where do you make that break so you have enough left over to use these alternate technologies.
What's your average rates that you have for your towers and your antennas for Just basic, like in the rural area, for example.
That's a great question. I don't know.
I don't know if you're like a 400 or higher
I know I've seen as high as like 700.
right,
I've seen a lot of water tower deployments.
Mhm.
That, you know,
church steeple kind of things.
yeah, things that are probably more in the 100, 200 foot range, so it varies. But
Permitting is probably one of the biggest things Vermont has.
Yeah.
It's a fun time when it comes to
the
towers.
cool thing is, with the cloud management system, I can do a quick database inquiry, and I could probably find that out for you in about 5 minutes. I can just average the tower heights across all the
Yep.
deployments. Haven't had that, I'm gonna have to
You
go
have
back
to
and
do
do
my
that
card.
math, so now I know, so I'll know.
Yeah.
So you had a figure earlier about, average cost per locations passed. I have to presume that those locations passed are also serviceable.
Yes.
Yeah.
Good. All right. Did I end on time?
Yeah, very good. We've got about 5 minutes. We're all gonna, Heron is gonna escort you to lunch. There's a beautiful cafe here, which I'm sure you'll all enjoy, but,
I have a question of curiosity,
Yes.
not Uni two,
You need to,
reason, power?
DFS, power, it's not an outdoor band. So I mean, there are some places internationally we might go to use it, but, DFS is always is sort of a nasty. I think we could use it outdoor in Europe,
Well, you can do it here.
not at the same power you can.
No.
Yeah. Yeah, and that's key. That's one of the reasons why CPOs perform so well is you have quite a bit more power than the unlicensed bands. Great.
so I hope your heads are all swimming with, technology thoughts. We're gonna come back here at 12:45. So we'll get started again. Ariana Robinson is here from VTEL, and she'll give about a 15-minute presentation on some of the options that are available for VTEL. But again, being technology agnostic, the point of this presentation is when you're looking at extremely high cost locations, don't forget to look at what existing services might be available, because they may be the least expensive. So whether that's a fiber extension or, proven wireless, that's, we want you to look at that as well. And then after that, we'll talk about the BEAD requirements. I'll introduce Clay Purvis here. Clay, if you want to stand up, I'll embarrass you.
Clay Purvis with the NTIA. Nice to see you.
Clay is here. He's our federal program officer. And you should know that information is coming in live in terms of what the requirements are. So we'll tell you the current status of the BEAD requirements. And Alexi Montserrat will present that. And then we'll get into the discussion around how do you as providers work within the framework that we've established at the state. At the state, we've built, you can go to our website, you can get what we call IPv1 and 2, which is our submittal to the NTIA and how we're going to do this. It's still in draft form. We're still finalizing negotiations with the NTIA. I don't expect substantial changes in that, but the timing is of this, there's such aggressive timing in this that we've got to keep moving. So, Mariana, take it away.
Thank you. Thank you all for letting me speak. I will apologize ahead of time. I'm an introverted engineer and a major fear of public speaking, so bear with me. In any case, I'm here representing don't forget about existing companies that are out there. Today, we can be of help with a focus on, of course, VTEL. I'm the Chief Technology Officer for VTEL. We are located, our main office is in Springfield, Vermont. We've been in business as VTEL since 1994 and have done a variety of things. I'll gloss through most of this, but traditionally a voice telephone operator, DSL early on, high penetration of broadband in our territory. We've deployed fiber to all of our homes within our telco territory, and we've also expanded
wireless out to cover a large portion of the state, some of what New Hampshire and upstate New York. We also operate a backhaul network, so we use that for other carriers, for larger customers, for getting to the internet, to get voice traffic, to get video. Lastly, we also operate a head end, TV head end in North Springfield, Vermont, where we do television services today for our fiber to the home customers. We aggregate the signals and send them out over IP. So if that comes up of anybody needing, let us know. I'm going to focus a bit on the wireless side of what we do, because that's for us one of the more interesting places. And I understand everybody's looking at how to reach some of the high cost areas other than fiber. So we have a variety of spectrum in our network today. It's licensed spectrum. We operate a lot today in the 700 megahertz and AWS frequencies, which are 700 megahertz and a combination of 1900 or 2100 and 1700 for AWS. We also have a large capacity in the 2.5 gigahertz range, which is the BRS and EBS spectrum. And we also have CBRS, which is priority access licenses, the PALs, as well as some millimeter wave 400 megahertz, really high up that we haven't really found the right use for today. Something that we are, and I apologize for rushing, I'm trying to keep everybody on schedule or catch us up a bit. Something we're trialing today, we're deploying a demo site to just show what we can do, or what we think we can do with that CBRS combined with our BRS spectrum. So it's a carrier aggregation play using commercial radios from Ericsson today, doing a aggregation between those two bands. So we're looking at doing 60 megahertz of our 2.5 gig spectrum and combining another 40 megahertz of those PAL CBRS licenses. In trials in labs, we've seen this pushing upwards of just about a gigabit of throughputs. We have the equipment deployed today on our demo site, and we're just doing the integration to start getting it out in the field and trying it at distance, between buildings or trees. We'd love to invite folks to come and check that out as, time permits. I understand there's a short time frame for everybody here. Mostly I'm here today as an invitation for all of you to, we would love to talk with each of you to understand your troublesome areas, existing carriers, wireless. We can't serve everything, just as you can't, but we might be able to help. We're another tool in the toolbox. I think I heard somebody mention that earlier. And I think that's probably a good approach, where either by upgrading existing towers that we have, of which we have approximately 150 across the state, with higher speed radios and access, we may be able to cover some of the locations that you have. Or even deploying new sites and tying into the existing core that we have for 4G and 5G services. Our door is open. Your areas very well, and we would love to explore it with each of you without going too far down a rabbit hole here of talking about scenarios, because every situation is different. So that being said, any questions?
Where's the demo?
Right now we're doing it in Rutland. The reason being, it's a more urban area, of course, but it's, we have a building there where we're deploying it on, which the access is easy and quick for us to make changes in tilts. We understand that that's not necessarily the final area we would want to see things in, but it gives us enough terrain in that area to test with.
Do you have a map of tower locations you could share?
Certainly would talk to folks and show you what we've got. And one of my colleagues, Gordon Matthews, is on the team, so he couldn't be here today, but would love to set up a meeting and do that.
Yeah, I guess that begs that we should send a contact list out after this meeting so that you can reach out.
That would be it.
Those different folks that presented today as well. as share other solutions. We'll be talking about other options later on this afternoon as well.
Easily reached by phone or email, and if that goes out, we'd love to hear from everybody. Thank you all.
Thank you. So at this point, I believe we're turning over to Alexi.
Yep, I'm here. I hope, can you hear me?
Yes, we can hear you well.
Okay, great. Then let me just pull up back.
So
Okay.
Alexi's,
Is that coming
Alexi's,
through?
yeah, that's good. He's been our project lead on the BEAD program. And he's also been the contact with the communication union districts, although he's moving into this BEAD role as we progress into this new funding source. Go ahead, Alexi.
Sure, thanks. So this is mostly just to sort of level set everybody. We've talked or alluded to the BEAD requirements throughout the course of the day. But we wanted to have a moment where we sort of really said out loud exactly what it is that we have right now. There are areas where there are guidance forthcoming. And so this will give you at least a good dose of how it is and when it is that we can turn to some of these alternative technologies in the course of executing the BEAD program. I do want to say, Christine alluded to it earlier, we have submitted our BEAD initial proposal volume 2 to the NTIA. It is not yet approved. Much of what I'm gonna go through here is straight out of NTIA guidance. But if there are areas where it becomes a little more Vermont specific, then I'll just remember that we're still in draft form here. So just to start out, initially, the first thing we had to do in the context of BEAD was develop a 5-year action plan. These are the indicators that we had set for ourselves as knowing that we had succeeded with BEAD. And this top one really is the main goal here and will shape the way in which we approach how we'll make selection and the priorities we have when we're looking at how to make the BEAD money go as far as possible. And that, again, really is this maximized priority broadband project deployments while ensuring that all underserved and as many underserved locations as possible gain access to high quality broadband. Here we have slices of what the NTIA guidance is. It appears in a few different places, but the core concept here when we start talking about alternative technologies is this idea of the extremely high cost per location threshold. And as you can see it here, the idea is to acknowledge that there are places that are going to be extremely expensive to get to and provide some way to account for those and cover them that in a way that doesn't end up being prohibitively expensive and taking all your BEAD money and spending it on too few locations in order to maximize most deployment that we can. And so you saw part of the slide earlier. I just wanted to also clarify or make sure it's clear from the NTIA's perspective what these alternative technology requirements are. So, there remain standards even when you turn to a non-fiber to the premises option. And so those are, again, it's the speeds that matter and the latency. So it's 100 up, 100 down and 20 up, and then a latency of no more than 100 milliseconds, which I believe everything we've been talking about today would cover.
Yeah, Lexi, just to add to that, there's a time element included, I believe as well. I mean, correct me if I'm wrong. It's supposed to meet that requirement 80% of the time. Do you remember the specifics on that? Or maybe Clay does.
So, right, that gets into a level of detail on some of the wireless technology where, correct, that 80% of the time these speeds need to be available. So that is true. So here, just again, just to clarify how the NTIA defines it, we found that a little confusing, so we made our own, adapted from that, which is also confusing. So I underlined a couple parts that I really wanted to make about it. In the course of evaluating the proposals, we have given ourselves the latitude to negotiate with the applicants in the event that, you know, the proposal comes in above the high cost threshold. And so that will be a process where we try to work with the prospective winner. If that can't be worked out, we have processes in place that would then allow us to turn to other proposals. I don't want to go deep into those details because, again, this is a draft situation. All of this is in our draft volume 2. So I'm guessing most of you are pretty familiar with that by this point. The other pieces that we have allowed ourselves to set this iteratively in a way that, again, in an effort to make sure that we're really maximizing fiber deployment while still maximizing coverage, will allow us to do that. And then the final point, I suppose, is that we may have different thresholds in different project areas. So understanding that some areas are more rural or have lower income or other elements that might mean that it makes sense to set a different threshold in one area than another, we've given ourselves the latitude to do that. So just to clarify what the actual process is, and again, this is all from our draft volume 2. So we, in a sort of steps 1 through 3, we figure out what the bids are, how much that costs. We look at that against how much BEAD funding we have, and then we start working around setting the threshold in a way that maximizes the fiber deployment while also working to ensure wide coverage. We will do this after we receive the BEAD applications. That's partly so that we have a clearer sense of what we're looking at, but also to encourage people to put their best bid forward, so that, you know, we're not kind of lining out where our line is and people can then adjust accordingly. Again, sort of reiterating that we may have different thresholds in different areas, and that we then, you know, during that process would start negotiating with folks in order to meet our BEAD goals. So that is what I was going to sort of cover at the top line. I'm sure there are a lot of questions. I would just note that, again, there's some guidance that we are still awaiting from NTIA. We just got a little bit earlier today, so we're working to digest some of that. But to the degree that it makes sense, I'm happy to answer questions.
Yeah, Lexi, why don't you describe as well our bid areas and how that's going to work? I think that'd be of interest to people in the meeting.
Sure. So we have defined the initial project areas as the boundaries of a CUD or the boundaries of a town. In the instance of a town, it's possible to split that by wire center if that ends up being a more logical way to do it, given where facilities already exist. In the pre-proposal phase, we kind of have a two-step process. We are saying or we have suggested to the NTIA that we will allow in that process, we want to know if you plan to submit an application, if there are any requests that you would want to make to change the project area, and then what technologies that you would be proposing to utilize. And so then at that point, we would take that in, review where things stand, and then before obviously posting, opening the full proposal window, we would post those revised project areas if we make any changes.
Yeah, and a point to make here is that, this is, although, Act 71 set up communication union districts, we're making really a decision on who the successful bidder who the successful bidder is for these areas based on a set of criteria that you'll find in our filings. The point is, don't think you have, if you're a private provider and you want to apply for a BEAD grant, there's no favoritism here to the CUDs. We're going to take the best bid that comes in. I'll just make that very clear. And that's why you're all here. If you're interested in bidding in these areas, we welcome your bid. And that's really part of the discussion that we want to have for whatever time we use this afternoon to say, what are your questions if you're interested in bidding on any of these areas? And there is flexibility if you look in terms of how we set up the bid process. We've defined the areas, but the areas can be modified based on proposals.
Christine, question? Briefly, extremely high cost locations to be served don't necessarily match nicely with wireline demarcations. This may or may not be an issue, but I'm just kind of curious.
Yes, they don't.
So as a criteria, is that an issue?
Yeah, maybe Alexi, again, Alexi's the expert here and plays here as well. But the point is, how are we gonna handle those extremely high cost locations? I thought some guidance come through today. I don't really know. I'll have Alexi or take that one on.
Yeah, so I think that your question is, in the event that a high cost location is somewhere in the midst of a theoretical project area, what do you do? The answer is not fully clear. However, I would note that a project area under BEAD can be a single address. And so to the extent that if you're looking to figure out where it does and doesn't make sense to submit an all fiber proposal, that you can take that into consideration. And
maybe we're talking about alternate technologies, let's say wireless, fixed wireless, okay?
Yeah.
When you put these things up, if you're gonna spend $50,000, $60,000, $70,000, you're not gonna do that for a single location. You're gonna try and spread that across a number of extremely high cost locations to be served, and they could be all over the place.
Yeah, that's kind of why we're here. Your question's a good one. That's really why we're here, Alexi. If we talk about these, where are these extremely high cost locations going to be?
Yes.
They're going to be individuals, they're going to be pockets. And that's really when it comes to, as a provider, you've got to do your calculation on your return on investment and, is this going to pay for itself?
Or it makes sense for the CUDs, all around.
Does it make sense? I'm not.
No, I mean, the math has to work for everyone. So.
That has to work for everybody. Yeah, that's right. I didn't know what you thought. Yeah. Yeah. So the point being, if it's a single location, you're certainly not going to put up, a central antenna and try.
Right.
That almost. I don't want to jump.
That would also be, of course, the cost that you would submit to us as an application for doing so would certainly be something we'd have to take into consideration when we're evaluating what alternate technologies might make the most sense for a given location.
And it may make sense to partner up with somebody to address a kind of bid area, if if you're the key, the three-step process, right? If you could talk about the three-step process, the first step is if it's an all-fiber solution.
Well, yeah.
Can you talk about that, Alexi? Yeah.
Sure. I don't want to get too far down into the various decision trees that we have. And I do want to say that one of the things that we're still waiting to clarify is the specific mechanism by which you would, as an applicant, try to manage the high cost locations. So for example, if you were to present a bid that included them and was therefore all fiber but higher cost versus excluding them, etc. And then the process by which you may or may not be able to engage directly with an alternate technology provider in order to, in the context of your own application. So that is TBD at this point. Again, we're eagerly working with NTIA to clarify some of these questions. And if I'm misspeaking, I welcome Clay, not to put you on the spot, but if you want to clarify anything I'm saying, I certainly welcome that.
Sure. No, I think you're right in pointing out that guidance is forthcoming from the NTIA. We did recently release technology selection guidance, which I think we're all still trying to digest as it just came out. However, we will have guidance on alternative technologies coming out soon, which I think will answer a lot of these questions. I would add on the extremely high cost per location threshold discussion that it's, really the average cost per location for the entire project. So you could have individual addresses that by themselves, the cost exceeds the extremely high cost per location threshold, but the overall project may be below. So you're gonna, it's gonna average out. The other point that I would make is that the threshold is a tool that the VCBB, the state can invoke at its discretion. So just because a project exceeds the extremely high cost per location threshold doesn't mean that this process is necessarily triggered. As long as the state can afford to provide universal coverage, a particular project might not actually invoke, subject to the extremely high cost per location threshold. So it is a tool for, in the first instance, being able to select a lower cost technology to meet the 100% requirement. There may be opportunities for a applicant to do a mixed priority, non-priority project. That would be a non-priority project because it's not 100% end-to-end fiber, but may qualify, as a reliable broadband project without having to resort to alternative technologies. That alternative technology is really the last resort, and you cannot do anything else. But I think you said that, Alexi, so I apologize for repeating.
Yeah, it's
No, that's fine. It does not hurt to repeat things.
one of the questions you may all be asking yourself is why you have these workshops, things haven't worked out. And I will say, the one thing that we're nervous about is we're on a strict federal timeline that's completely not flexible. So regardless of how long it takes for the NTIA to make their decisions and all this, we don't get any flexibility in our schedule. So maybe you could talk briefly about schedule when we're gonna do pre-proposal, and other phases, Alexi.
Sure. Again, recognizing that, a lot of this is subject to approval of our volume two. Again, we're hoping that happens soon. But once that happens, then we can, release what will be our request for applications as the eligible entity for BEAD. That will help people start to get their heads around what this is all going to look like. And then we will be doing a series of trainings on the different elements of these things. At present, we're hoping that the that process would happen this summer at some point, that the pre-proposal window would open in late summer, early fall. We'll need some time to take all that in and calculate the final project areas. And then with an opening of the final proposal window sometime mid-fall, and then that will start to get contingent on how many applications that we receive and et cetera. But ideally making some decisions around that and submitting our final proposal to the NTIA in the winter. And so, but again, it really does depend on some approvals that we're still waiting for.
And what's our drop dead date for having everything completed?
I believe the man behind you may have, or I guess he's in front of you. He's behind you on my screen.
Everything all done.
I don't,
Yeah.
you know,
I mean, 365 days from the date your initial proposal is approved. So you'll get a notice from NIST with that date in there. And then you're off to the races.
Yeah, so,
Yeah.
so that's, so we still have a little over a year, right, before we.
Right, because it's not approved. It hasn't started yet.
not approved yet, so that clock has not started yet. But once it does, then yeah, we're off and running. And clearly everyone wants to get started, so we feel it incumbent upon ourselves to do that quickly and make sure while making sure everyone is prepared and understands what's happening.
We have 2 questions in the chat.
We have 2 questions in the chat. Can you read them out?
Yes.
Go ahead, speak loud.
The first one is, what is the average cost anticipated for unserved customers for Vermont?
You hear that question?
So I think what you're asking is the average cost per location statewide?
Down to the cent, please.
Yeah, down to the cent, please.
Well, I'm reading
Yeah,
what was written.
Oh, right.
I don't
Oh, I'm sorry. Of course, it is.
I'll tell you,
no,
I'll answer.
you don't know. So do you want to grab that one, Christine? You've got those numbers in your head pretty well. This was an estimate that we did run. You can actually find it in our 5-year action plan. But I believe it was around 8,500 per address as an average statewide. That estimate, and again, all of the details are in our 5-year plan. It took historical data on actual cost of construction projects in similar densities and did some averaging out across all of that. And then when it comes to total Vermont addresses, unserved and underserved, it depends a little bit on what category you're putting that in. There's a few different sort of ways that they calculate those things. And then our total BEAD funding is, but that number, Christine, if I'm not mistaken, is somewhere around 24,000 between the two.
So
And-
Let me pull the questions up. I can see.
yeah, they can't see the question. Sorry.
Hang on. Set that up. Hang on.
So you were answering and no one knew what you were sort of answering to.
What is it? So what is the average cost anticipated for unserved customers in Vermont? I think Alexi answered that actually.
That's
the next-
I don't have it right in front of me, but I believe it was around 8,500.
Okay, so I'll say this aloud. What is the total Vermont BEAD addresses that are under and unserved? And then what is the total BEAD funding? So,
That's around, the total addresses, if I'm not mistaken, was around 24,000 with the two combined on an underserved. And then the total BEAD funding, is 218 million. That includes everything, including some administrative costs and other planning costs. But that was our full allocation. You've asked how RDOF addresses are accounted for. Any and all already federally funded projects or even some private planning has been accounted for through what has been called the challenge process. We just ran that. We are in the process now of submitting that data to the NTIA in a way that we make sure is all correct and buttoned up. But so there was a formal process just to make sure that we as we refer to it, deduplicated any addresses that are already planned to be funded.
So that doesn't just include RDOF, it also includes enhanced aid.
Yeah.
Enhanced aid and other federal projects like USDA Act.
next question is how are RDOF addresses counted for?
And just answer that.
Yeah, sorry, that's the one I just got.
Calculator safe.
What's that?
Did you calculate the?
Yeah, it's pretty close to it. What Alexi just said, 8750 or something, yeah, so he said 8,500, yeah. Your math was good, you were within a few percent.
You just took the remaining and divided into the 249.
Yeah, 218 million, yeah.
Came up with an average.
That's, I don't know if that question was a test, but you passed. Okay,
So I want to rephrase something that was said in the morning, as kind of a question. There's so much money available to the state, BEAD and the other grant programs. And there's so much to build, and there's an estimate of what it's going to cost to do everything in fiber, and there's a difference, right?
yes,
And the way you're going to make up that difference is by dividing off some of it as extra high cost locations and funding them at a lower level by alternative technology. Is that right?
that's correct, yeah.
So
The amount of match that's provided will also impact that too. Like we said, that's 229 or 218 or whatever it is now, but there's also on top of that, providers are required to submit more than 25% match.
okay, thank you. So logically, it would, if we want to cover every single location, and I think we need to, then the planning requires that the fiber builds get cut off at a certain point to leave enough funding to cover the extra cost locations, even though some of them might be easily served by fiber. Because so you have these two principles you're talking about. You want to do the maximum extent of fiber, but you also want to cover every location. And if you go to the maximum extent of fiber, you won't have enough money to cover every location. So there's some point back that you have to draw a line. Is that how you're thinking about it?
This is the art of the setting that high cost location threshold and what the applications look like and negotiating that.
Yeah, so let me give you the high level math to answer that question. It is an art, and our estimate is somewhere around 630 million or so to get fiber to the majority of the risk. So there's always, we're not from the NTI set up these rules to make sure, we don't go spend $100,000 to get to that, fiber to that house a mile or so up the road. There are certain addresses, no matter how we do this, 299,999 broadband services locations in the state, you're gonna have at least one or two that just don't make sense to run fiber to, right? So that's the theory behind it. But getting to what you're saying, we believe we have between the BEAD funding and the ARPA funding and what's been provided by the state as well as various other buckets. We believe we have enough money to get to the majority of the locations. And that the majority is the trick word, right? What does majority mean? Is it 98%? Hopefully it's greater than 98%, but we don't know. That's why we have to get through this exercise of setting the high cost location to determine where that cutoff is. Our goal is, I can't imagine where we would arbitrarily stop with fiber and not go to the next house, right? Because that would probably be the lowest cost solution anyhow, right? If depending, as long as that house is not 2 miles up the road. But if the house is typical, we're running 6 or 8 passings per mile, a fiber extension makes sense to a certain point. But it doesn't make sense everywhere. Does that make sense? Did I guess?
Are we not splitting hairs here? Because high cost, if we exclude off grid, they don't have electrical service, whatever.
Yeah.
Chuck them aside. Every house is passable. And what we're arguing over, debating has high cost locations, is really high drop cost locations. We've got so many addresses in this state that it's easy to get to the beginning of their driveway, and you start a whole other project to get to the end of their driveway.
Yeah.
And how many of these locations are you then going to say, oh, we can go past 50 homes on a road, but every single one of them is a high cost location because these McMansions up and down the streets are, you're a quarter mile up that road, 2 miles up that road, 5 miles up that road. It's just a driveway. And these people who have come and settled here with their McMansions, oh, I don't want to spend the money on the conduit to come back to the front. It's like, we're arguing over high cost. There's no high cost areas. There's high drop costs. And since BEAD is insisting on the drop being included in the price, you're gonna have these 8,500, that's a joke.
Yeah.
When you want to average out the cost. But the cost, I mean, it's one thing to be, we try to do the equity and bring the low income of us are not sitting at high drop costs. We're trying to find ways to use public money to serve a well-off group of people or people who have elected to be as rural as they possibly could be. But we don't really have any high cost areas. We just have high drop costs. And would it not be more feasible to do what we can with the money we have? I think all those technologies are really quite cool, do not address high drop costs because they have to be one-offs, one at a time. Put one thing on one pole, feed that truck. One thing on one pole, feed that truck. None of those technologies do that. And the wireless bit's cute and all, but as soon as you do wireless, you've blanketed an area. Why are you doing any fiber? You're splitting hairs. You take the submissions, you do as many addresses as you can, and then hopefully you have enough operating revenue to then continue to take half steps towards the rest of it. And someday we get there.
Well, I understand that theory or that statement, but we have requirements that were set through Act 71, our legislation, to get to every on-grid address in the state, and the NTIA, federal government, has set a goal to get to universal service. So therefore, and when I always defend Clay and the NTIA because they're doing the best, they're building the best program they can within the confines they've been given from Congress. So Congress says we want Congress, somebody somewhere, whether it's president or Congress, whoever, I'm not getting the politics of it, but says, okay, or it would be me running for governor, right? Anyway, we're gonna get to every address, right? Well, the reality is when you make that statement and you have a fixed amount of money, well, then you, by definition, the way to get there is through defining an extremely high cost location. So if you've got a McMansion up a 2 mile driveway, that's gonna cost you, my utility experience, I'm just gonna go for my utility numbers of $130,000 a mile, which is probably not that expensive, call it 100,000 a mile. And you have that $200,000 to run location, we're not gonna run fiber to it. Then it's gonna fall out of the extremely high cost location. And we'll look at alternative technologies and the bottom, I'm not gonna say the bottom of the list, that was wrong, but Starlink is there, right? Starlink is there as a solution.
But then Starlink's everyone's.
Did I say, Clay, is that kind of accurate? But
Yeah, I think so. You know, I think to get at that issue that you raised is just not something the program is set up for.
I mean,
We're doing broadband.
in the early 1900s, they did rural universal service for electrical grids, and every
Oh, that,
has electricity. in Vermont
as a
today.
former Vermont co-op CEO, 1935, FDR signed.
Yeah.
But the problem is, the telecom's not a regulated service. So what's happened over the time is, because it's not regulated, we have, CUDs that have built their business plan on, 4,000 addresses. By the time they get to that 2,000th address, another provider came in and stole 1,000 of them, right? So the cherry picking is, we're dealing with an unregulated process here. And Grant, I agree with you. The cooperative solution would have been a much better solution, but we're just not even there, right? Anyway, yeah.
Yeah, I had a question on if there's, and I might have missed it somewhere, on the definition of where the extension of the fiber network is, say, on like serving poles, right? That it goes to more, it can end and be counted as serving when it goes to a pole that serves, 2 BSLs, right? Instead of, because I had a similar question on these long driveways. It's like, who's paying for the drops? Does it mean we have to go right to their house, or we say, hey, where the network ends, for 2 or more, the rest are private poles to a house or underground conduit from there, however it may be, but the network can reach it and say, hey, you have service, you have to get from your house, the network, or subsidized in some way, but that the network is there, right? Rather than going 1 mile this way for that person, 1 mile that way arbitrarily, just using numbers.
In the context of the speed program, those drop costs have to be accounted for. And so that is going to be a factor, as Mike was talking about, that
The structure to just the
that
actual
comes,
drop.
that gets factored in. So that is not the case for the ARPA funding, for example. But our standard is that, for BEAD is that drop has to be included. That's the federal standard, I should say, not ours.
So you hope this.
Yeah, go ahead, Mary.
So I have a question going way back on
Okay.
about the territory and when you're applying for BEADs, and you said it could be done at a town level or at the CUD base level or et cetera, et cetera. So say if somebody came in prospectively as me as a CUD and they came into couple of my towns and they said, out BEAD.
Sorry, yeah, I wasn't clear on that, sorry. It is a CUD, and in an area where there is no CUD, it is a town boundary.
Thank you. That makes more sense.
Didn't mean to confuse.
Oh, that's what we have. Sure.
So I'll read Kim, I think Kim Gates made a statement, but I think we just covered it. The goal is to reach all addresses that will be more efficient to fund existing providers that have the backbone infrastructure. That's a point.
Yeah, I think that's what.
In that event, it is a competitive program, and so those providers can put forward a bid.
Good answer.
Yep.
Yes.
So if a non-CUD provider wanted to put in a bid that would be welcomed and wants to serve an area that's within a CUD, there's a requirement to serve the entire CUD with the proposal, is that correct?
That is correct.
And didn't Act
You have to do
71,
an entire project area, right? So and we're saying that the initial project area is a CUD, or if not, if there is no CUD, then a town. Again, in the pre-proposal phase, someone could propose a change to a project area, but we would evaluate that based on its merits.
okay, so the rest of my question is, Act 71 stated that private providers, independent telephone companies, cable companies are welcome to apply as long as they're working in conjunction with a CUD. Is that still the policy?
But the NTI policies override state policies. They're the funders. They're providing this funding with a set of requirements. So therefore, we have to comply with those requirements.
There's nothing stopping you from entering into a consortium with another provider, whether that's a CUD or another provider to serve the whole area.
Right. But so that provision has been overridden by the NTIA rules, is that what you're saying?
With this funding source, yes.
Okay.
I think Alexi has to go, but I didn't know if there's any last questions. Christine and I and others can probably also assist with this.
Oh, yeah.
I solved the problem I had, so I'm good.
Okay, good. Other questions?
Lexi, Stephen John here, how's this gonna work for the state?
It's gonna work very well.
It's a big question. It's a big question. I think we're all struggling with how are we gonna reach that end goal? And is there any hope? Because right now, most of us just see an impossible gap between our funding and what we gotta do to get it done. Even if we included any percentage of our CUDs in one of these alternate methods of receiving service. So I know we're gonna receive more guidance about about applying and about the funding and all, but the big numbers just don't add up for me. Unless there's a path via legislation or private funding that's gonna get us there. Am I missing a point?
Yeah, I don't think we necessarily know the answer to that. That is definitely a legitimate fear. It's certainly my fear. I think it's a fear of many of the states, probably all of them. This is it's the old story, don't look the gift horse in the mouth. We have an unprecedented amount of money coming to us.
Yeah.
Which we're trying to maximize and take best advantage of. And again, I think, there's fine tuning around this program, but I actually think the NTI has come up with the best way to do it. But is it enough? We won't know the answer to that till we get through the process.
It's enough to get started.
It's not, yeah, I'm not.
Our expectations are we can't fail for you either. Our expectations is we have to serve every service addressed.
That's right.
The universal service plan, whether you think we're up to it or not, we're required to do it. And we financially need to be viable to do that at the same time.
Yes.
Yeah, and that's the concern our board members, universally makes them anxious that we apply and we get this grant and it gets us 3/4 of the way there. We raise all the money we can to do the 25% and match, and then we still are falling short of what the requirements are of the grant. And I can understand the motivation there. We want to get the most out of our money, but the public money. But anyway, I just wanted to, I just want to allay the concerns of my fellow board members about there being some prospects of things happening. And I don't think this kind of meeting is very encouraging, but it isn't meant to be. I understand that. The reality in the weeds of deciding, okay, once we get a threshold or we figure out where our high cost places are, we have to figure out within our own district where, what method is going to be used to reach them and how much that's going to cost, and include that in our calculation of a big grant application.
Well, if you multiply.
This is where, Christine, if I can, so this is where we as the VCBB have a unique situation, sort of nationwide, in that we have these CUDs and we have a dual responsibility in this sense one from Act 71 with the grants via the ARPA process, and the other with the BEAD program. To the extent that we're able to have some of these discussions, it becomes important for us to remember that BEAD is a competitive program, and that when we are thinking through how it is that the CUDs accomplish some of these things, there are lines that we can't step across. And so I just want to emphasize that while we work with you in a lot of ways, in order to figure out how we're going to get this all done, there are elements to this BEAD part where we have to be more circumscribed.
Thank you. Yeah, and I will say too, the most important thing is to have a sustainable business plan. I think, so I wouldn't apply for any of these grants if you don't believe that you've got a sustainable business plan. Because ultimately, what's our third option if we don't get any bids? Alexi?
If we don't have any bids, then we have some latitude to go out and talk to folks directly.
Again?
So if there were no bid for a project area, I think that's what you're talking about, Christine. Then per draft volume 2, we do have latitude as VCBB to engage with providers to see what we can do to get those areas covered.
And if you do the math, the estimates have been given from Starlink is, $5,000, right? So we can get everybody covered. It just would, if you take $5,000 and multiply it times 25,000, it's less than 218 million. So
If you want to cut down your trees. Well,
No, sorry.
not, yeah, but it's, and that's less than your $8,500.
yeah, right,
cost.
yeah, right.
So as Michael was asking earlier, you can move the needle or the sliding scale and then, make up the difference.
Yeah, and that's where, it's tough because there are a hierarchy of priorities. So this is probably more a question to you, Clay. I assume the highest priority is get universal coverage. Is that correct?
Yes, I mean, that's the whole scheme we've developed with the extremely high cost per local threshold.
Yeah.
And by definition, universal coverage means fiber.
No, universal coverage means reliable broadband, which is a defined term. Think 100 megabits down, 20 up.
Okay.
Less than 100 millisecond latency, and is not satellites or unlicensed wireless. So that actually includes a lot of technologies that qualify as long as they can get the 100 down, 20 up. But the NOFO, our rules, in other words, prioritize fiber. We want to see as much fiber as possible, so that's why we have end-to-end fiber. Projects that are 100% end-to-end fiber are considered priority projects. That is the priority that the VCBB needs to set. Get as many of those locations served with end-to-end fiber as possible. And then the next tier down is the non-priority projects. That's any other reliable broadband service that is not fiber. And then as a last resort, alternative technologies. That's your low Earth orbiting satellite, your unlicensed wireless.
So those are all priorities dependent on available funding. I mean,
Yes.
that's what defines the priority.
Yeah, and so I'll go to the positive spin on this. I've been working on this since 2003 as CEO of Vermont Electric Co-op, as a rural Vermonter who doesn't have service at all today. This is if they got 100 over 20, they're gonna be happy. The goal is to get fiber, but a higher order goal is to get universal service. So we know we've got enough money to do that. It's just picking that point, which is why the plan that I had little to do with the staff's work, and Alexi and Rob and everybody gets credit for it. I think this is a very elegant plan. in terms of how we get there, because we didn't define the extremely high cost location. Right now, we're gonna look at the data first to ensure we get there. And that is gonna cost, that's gonna cost some heartburn with some folks that like me, who was hoping to get fiber to every address in the state, but
Yeah.
universal service.
So I kind of want to see if there are other questions around any of the beat specific things, or I think we were going to continue to discuss the technology. So I just was trying to be mindful of time.
Yeah, I think we just open up to questions in general. I mean, technology wise, there's, I was actually happy that VTEL came in and covered that, look at the existing services that you can get, if it's a line extension. That earlier question around if, do we, Michael asked the question, do we stop at house A when house B is, next door? No, of course not. That's probably gonna be the low cost solution, right? So that's why looking at our goal to get fiber and our goal to get universal service is really, it depends on how well we do this, if we've got every technology, we turn every stone and do the lowest cost solution, whether it's copper for sub-kilometer copper, whether it's, ubiquity dishes or whatever. We want to look, we're now down to an address by address solution.
Yeah.
What's the best solution for this address? That allows us to maximize the funding. And that, we're at the hard work, right? We picked the low hanging fruit, now we're at the hard work. And I think it's an engineering challenge.
Alexei, do you want to speak about some of the other trainings that are coming up?
Sure. So, as I mentioned, there are a whole bunch of requirements within this program. I know many of you are aware. So, the items that we're going to be working through include the permitting process, the BABA, the Build America, Buy America compliance, Davis-Bacon compliance, looking at the workforce requirements. So there are any number, I believe we're looking at about 5 separate, essentially workshops to work through some of those issues. And again, the big moment will be when we have volume 2 approved and we're able to then release the actual RFA that we'll be providing, and then you'll have something really much more tangible to get your hands around for BEAD. And hopefully those will be happening again throughout later in the summer.
And don't let the
And there will
application
be,
process.
sorry, just one, sorry. There will also be a training on the RFA itself. So that'll be essentially the lead off thing. And some of you may remember our colleague Lucy Rogers, so she'll be shepherding you through that process.
Yeah, that's exactly where it's going. Don't let any of this intimidate you. We do want the best solution wherever it comes from. So, whether you're a small provider or a large provider, we want to work with you on the best solution.
The workforce is already scheduled. The workforce, most of you must have gotten the invitation, right, Karen?
We sent out the save the date yesterday, but our workforce workshop is scheduled for July 17th with more details.
July 19th, right?
July 19th, I'm sorry. More details coming.
Yeah, so that's our next workshop, is on workforce development. If you're curiosity, just go to the NOFO and read pages 56 through 59. That's where the workforce development requirements are. But we'll be giving a workshop on that, as bidders are required to address some of the basic workforce goals that are set in the BEAD program. Any other questions? Thank you all for coming, and stay tuned.
Yeah, thank you for having this.
Yeah.
You're welcome.